All right, so these are the objectives that we're gonna do. We're gonna use sine rule. So we want to understand how to use sine rule to calculate a missing length as well as a missing angle. In order to do this, we need to understand the conditions necessary in order to make this happen. Another thing that we're gonna look at is how do we calculate the area of a triangle using sine. And this particular skill is usually used when we have two lengths and an included angle and we do not have the perpendicular length. All right, so take down these objectives and after we'll go through it step by step. So sine rule. So this rule basically used to calculate the missing length or angle of a triangle, right? And it doesn't matter if it's a right angle triangle or not. The only thing that you require to have is whatever conditions are necessary to be able to calculate it. Okay, so it doesn't matter if it's a right angle triangle or not. So say for instance when we're talking about SOHCAHTOA, those are usually used for right angle triangles or if you're looking at a perpendicular length. But cosine and sine rule, once conditions are met, you can use either one of them for any triangle. Now this equation basically compares the ratios of the sines of the angles to their lengths, right? So as you can see here, we have a length here divided by the sine of the opposite angle. So for instance, let's say we had an angle here called capital A or big A. The opposite length would be here, which would be common or small a, right? So therefore we would say that A over sine A is equal to, say for instance we had B now. So this is angle B and the opposite length is common B. So we are saying that A over sine A is equal to B over sine B, which is also equal to C over sine C. All right, so what we are saying is based on sine rule, these ratios, once we divide them, would equal the same. All right, so therefore when we're actually using the formula, we can use this to answer the question. So you'll see that in a bit. We will explain this. So I want you guys to take this down and then after we will talk about the conditions required in order to use it to either calculate the missing length or the missing angle. This one is a very easy one to use, right? This one is very straightforward. You just have to practice it to ensure that you have a good grasp of how it's done. The next trick is when we combine in different triangles, you have to figure out now which one do you use in which situation. So we're going to do an activity later to help us figure that out, and that's something that y'all will work on during the week to improve your skills on this area as well. If we want to calculate a missing angle, we must have two lengths and a non-included angle. So if we have a length here called A and a length here called B, we must have at least one angle that's not an included angle. So in this case, A here is not an included angle. Remember, an included angle, so let's say if A was an included angle, we would have a number here and a number here. So it's like we have these two lengths and then this would be the included angle. However, in this case, we have an angle but it's not an included angle. So these two lengths and the included angle allows us to be able to work out the missing angle. So we could work out what this angle here is based off of what we have here. Now as it relates to the missing length, we must have two angles and one length. So say we have this angle here, angle A, and we also have this angle here, angle B, and we only have the length of B. We could work out what A is. So take these down, and also bear in mind if you have two angles, you could also figure out what the other angle is. So even if they set up a question where you have an angle here and say for instance one here and you don't have the angle for this, obviously you could work this out because why? Angles that are internal for a triangle, they all add up to 180. So if you didn't know what this is and you need it for this, you just need to work out what it is, because A plus C plus B should add up to 180. So once you take this on, we'll try to do a question that involves us trying to calculate either a missing length or a missing angle. Alright, so the next thing here that we have now, right? So we want to calculate the missing length using sine rule, right? So what are the conditions that we need to have for that? What should we have based on our notes? So if we're trying to calculate the missing length, we must have two angles and one length. Right now we have two angles and one length, which means we must be able to use, we must use sine rule. So if you look at this, in order to calculate a missing length, we must have two angles and one length. So let's try it now. So what we're gonna have here, we're gonna have A over sine A is equal to B over sine B. Now remember, in this case, A represents the length, so we could say, okay, my length here, I don't know what this length is. I'm just gonna say it's A. The angle here has to be the opposite. So if this line is A, that means this 60 has to be capital A. Now I could choose whatever I want A to be, or what B to B, or C to B, or whatever the case is. So in this case, I could have B here and B here, but I just need to make sure that they are the same, opposite from each other. So in this case, now I'm going to call this one here capital B because it's an angle, and call this common B or small b. So now, what is A? I don't know what A is. So I'm going to just leave it here as A over, what's this? Sine 60. So I'll put here sine 60, which is equal to B, and B is 15. So I'll say 15 over sine, what is capital B? 40. All right. So now my next step would be to work out what these sine values actually give me. And how many decimal places do we usually put them to? We put them to 3. So what you can say is we have A over sine 60. So we could say here sine 60, and we get 0.866. So here now we have 0.866, which is equal to 15 over sine 40. So now I could say sine 40, which is 0.64, and since this is a 2, I'll raise it to 3 because of this 7 here. So it's going to round up to 0.643. So sine 40 is 0.643. Now my next step, I have to cross multiply in order to figure out what A is. So A times 0.643, just like we're doing a cross, and then 15 times 0.866. So that's why we do cross multiplication. We call it cross multiplication because they're going like A times the bottom part and the top part times the bottom part again. So now I could say A times 0.643 would give me 0.643A, okay, which is equal to 15 times 0.866. So this is going to give me 0.643A, and now I need to work out what 15 times 0.866 will give me. So I'll go to my calculator. 12.99. Nice. So 15, excellent. So 15 times 0.866, 12.99. Wonderful. Good work. So 12.99. Now, we need to get the A by itself. I'm just writing each and every single step so you can see it step by step by step what's going on here. So this here was like step 1, step 2, step 3, 4, 5, and then this part is going to be like 6. Okay? So, how do I get the A by itself? What is being done to the A? A number is being multiplied to it. So I have to do the opposite of multiplication, which is what? Division. Excellent. So I divide both sides by 0.643. 0.643. So when this cancels out each other, I'll be left with A, which is equal to 12.99 divided by 0.643. We could say here 12.99 divided by 0.643, which gives us 20.20. So it's almost like 2020. So 20.20, and then I'll put here centimeters. So this is when we're calculating the missing length. So take this down and we'll try one for the calculating the missing angle. So this basically repeats itself. Whenever you have to calculate a length, this is the process you use for sine rule. Then when you have to find a missing angle, it's the same process that you use as well. I'm giving you each and every example and how to use it. Alright, so for this one, we want to calculate the missing angle when we are using sine rule. So we want to calculate the missing angle using sine rule. Now in order to do this, we must have two lengths that we know of and a non-included angle. So you see, like we spoke about here, We have two lengths and a non-included angle. So as you can see from this, we have two lengths and a non-included angle. So in order to use sine rule to calculate the missing angle, we must have two lengths and a non-included angle. So this here is a non-included angle. If we did have an included angle for these two lengths, what would have happened is we would have had an angle in here given to us, which makes this the included angle for 16 and 12. However, we do not have an included angle. All right, so we set up the same way. We have the same sine rule formula. So we write this down. So A over sine A, which is equal to B over sine B. Now, if I'm to label this, I can say, okay, this here is A. For no particular reason, I just labeling this as A, and this here as capital A. I just need to make sure that if this is capital A, the opposite length is common A. So likewise, if this length therefore is B, then the opposite angle for this here would be B as well. So now I could stick this into my formula and go. So A, I replace A with 16. So 16 over sine A. I don't know what sine A is, so that's why I'm putting it back as sine A. All right. So then now I'll say that is equal to B, which is 12. So 12 over sine B, and B is 42. So I can say sine 42. All right. So as usual, we always try to figure out what the sine is. Sine 42, what is that? So let's write this back down. So we'll have 16 over sine A, which we do not know what it is. That's what we're looking for, which is equal to 12 over sine 42. So we want to figure out what sine 42 is. So we say sine 42, which is equal to 0.669. 0.669. So sine 42 is equal to 0.669. And based off of the last time, what did we do? What did we do after this? We crossed multiply. So that means we multiply this 16 at the top to the bottom number on the other side. And we multiply this 12 to the bottom number, sine A, on the other side. All right. So then what we would say here is we have 16 times 0.669, which is equal to 12 sine A. So 16 times 0.669, what does that give us? 16 times 0.669, what y'all get for that? Y'all get the same thing as me? Lovely. So then we're doing something right then. So we got here 10.704. I'll put it as 3 decimal places because we want to calculate the angle. Okay, only because I want to calculate the angle is why I'm doing that. So now, I want to get sine A by itself. Alright, so this is the steps that we had to take so far. So in order to get sine A by itself, I need to do what? What is being done to sine A? 12 is doing what? Multiplying. So we have to do the opposite of multiplying, which is dividing. So you divide both sides by 12. Once I do that, I'm leaving sine A by itself. So now I can go on the calculator and do 10.704 divided by 12. That leaves me with 0.892. So right here would be 0.892. Now what's the opposite of sine? If we want to get A by itself, we need to do the opposite of sine. What did we say the opposite of sine or the opposite of cosine or tan is? Sine inverse. Excellent. So we know that A would essentially be equal to the inverse of sine and then 0.892. Okay, so we can put that in the calculator now. So inverse sine, then we have 0.892, which gives us 63.125. This 5 can turn this 2 into a 3, so we'll have 63.13 degrees. So 63.13 degrees would be equal to our angle A. So we know that the angle here is 63.13. Now that we have all two angles, if we wanted to calculate this angle, we can too, because we have two angles. So these two angles can add together, subtract it from 180 to give us this, and we have all three angles. And we could use sine rule again to calculate this length if we wanted to as well. Alright, so this is our answer here, and that's how we use sine rule to calculate a missing length and a missing angle. Was that easy? Nice. Alright, so take this down, and then after I'll show you how we could use sine to calculate the area of a triangle when we do not have the perpendicular length. Alright, so we could use this formula to calculate the area of a triangle. Usually we use a formula that is written like this: half times the base times the height, which is referred to as a perpendicular height. Okay, the perpendicular height. So if we had a triangle and it has a perpendicular height, so this is a perpendicular height, or even if it's sideways like this, and we know the perpendicular height, which is here, and perpendicular meaning the height is the right angle height, or the perpendicular height from the base, so the height that forms a right angle at the base. So if this is a base, we need a perpendicular height. So this here would be the perpendicular height, and here in this case would be the perpendicular height. So if these are usually given to us, then we use this formula. Now, for situations where we do not have perpendicular heights, say we have this triangle but we do not know the perpendicular height here, but they give us a length here which is A, and a length here which is B, and an angle here which is C, or in other words the included angle, we can use this formula. So notice here, if this was a situation where we could have used this formula, we would have had a perpendicular height. So what do you mean by that? In that case, we would have the height of this. We would have known what the height of this is. But if we are not given that perpendicular height, but we have two lengths and an included angle, we can calculate the area using this formula here. Just a reminder, the included angle is the angle that is formed between two lengths. So the included angle of A and B would be C. So as you can see here, A is here, which represents this. B is here, which represents this. And we have the angle C, which is here. So that's why we need all three of these variables in order to calculate the area. So take this down, and then after we'll do an example like this as well too, so you can see. Alright, so looking at this one here, right? So we have two lengths and an included angle. These will be the conditions that we need to have in order to calculate the area of a triangle. As you can see here, we have a base, but we do not have a perpendicular height. So this is why we have to use this formula. And we know that we have two lengths and an included angle. So remember, this is the included angle because it is between the two lengths given. All right. So A and B would represent the two lengths. So this could be A, or this could be A, or this could be B, or this could be B. So I'm just going to call this A because it's the first one, and I'm calling this B because it's the second one. So then here now is the only angle that we need to have, which is the included angle, and we're going to call that C. So this here is the capital C. Okay, we haven't done anything that is difficult as yet. So in order to calculate the area, we know that the area is equal to this. So we say that area is equal to half AB sine C. So therefore the area is equal to half of AB. So A is what? A is 10. So half times 10 multiplied by B. What is B? What is the value of B? 12 centimeters. Excellent. So we put 12 here multiplied by sine of what? The sine of what usually goes here? 40. Exactly. So this here would be 40 degrees. Okay. Now we could work this out. So I could say half times 10 times 12. All right. So half times 10 times 12. And the beauty about this is I could put sine 40 one time because I have to also multiply it by sine 40. So I could say times sine 40. Alright, which gives me now 38.567, but because this 6 is more than 5, it has to go to 7. So I can say that the area is 38.57 centimeters squared. So 38.57 centimeters squared. and that's my area. Now another way, if you wasn't too sure how to do the half part, what you could do is basically multiply it. For instance, 10 times 12 times sine 40, right? This is the same thing. When you say half of that is the same thing as dividing by 2, okay? So then I would have put in the calculator 10 times 12 times sine 40. Alright, and then my last step is to divide this answer that I get. So whatever this answer is, so divided by 2. And that gives me the 38.57. Alright, so that's how we basically use this to calculate the area of a triangle. Very straightforward, just using this formula. And this formula also comes on the exam. Alright, so I'll send you guys some stuff for us to start practicing and trying, so that we can master our understanding of this concept. All right, so you have to be able to do this, and in order to do this, you just got to practice it. Once you practice these things, they become easier. It's like tying your shoes. The more you practice tying your shoes, eventually you got better at it. So now you reach a point where you could tie your shoes while talking, while hopping, while your eyes closed. You don't even need to look at when you're tying your shoes, because you have practiced it so much for such a long time. It's like second nature. So if we were to practice these things over and over, we're gonna make these second nature to us. Okay, and remember, we don't joke around with these things, we don't play around with maths. No play man thing here. We mash up maths. We make sure we do what we gotta do to be good at maths. Okay, and it's all about consistency and dedication. So I can send it to y'all now so y'all could practice, so we could get better at this.